Okay, thank you. So yes, Simon Kraatz. I'm working at USDA in Beltsville, and I'm reporting on, our temporary kind of networks for validating the new satellite mission data. So unfortunately, there's no data in there because let me tell you, we only have NISAR data from October to January. It's not the best data. My in situ stations they kicked in at in April. So I'll talk more about that. But I do have maps and evaluation, but just not for this talk. It's just preliminary still. So here. So we at USDA, we are of course very interested in soil moisture. That was one of the stakeholder needs to do better at soil moisture. And so now we have this new satellite mission coming up, NASA-ISRO Synthetic Aperture Radar mission, and they produce three soil moisture products. So interestingly, just as an aside, it's not really part of the science algorithm. It's kind of like an add-on, this three soil moisture algorithms. And that's also why it's a little bit the odd one out when you come to look at the data. And in fact, so this soil moisture product is the only thing that's a real product from NISA. You can download it and look at the maps. The other ones are just Python codes, and you have to run them yourself. Okay, just for your information. The only thing that's provided is the basic data like interferometric coherence, so geocoded SLC, or they call it GCOF. The other one that's basically what you would use for Sentinel-1 data is backscatter. So one challenge is these NISA products are going to be 200 by 200 meter grids, and all the existing networks that were used also for validating the SMAP data, etc. The stations are much more spaced out. So before they were in a 36-kilometer grid, right? We never really focused on 9-kilometer grids too much. But for NISA, we want to figure out how well the soil moisture products work. We want to have multiple stations ideally inside the 200 by 200 meter grid. So we have to set up new networks for that. And so yeah, even for SMAP, it's about a kilometer apart. So the other challenge is NISA is radar data. So unlike passive microwave data with SMAP, be more impacted by vegetation, by the soil structure, and soil moisture changes as well, or rain. So we can get some variation in the data. So there might be some inherent noisiness. Also, there's always a speckle noise with SAR data. Now, 200 meter, you would hope it's not that bad, but the problem is you might average trees into the calculation for soil moisture. So one of our sites is called BARC Agricultural Research Network, that we're setting up in Beltsville, and we're measuring multiple points of the inside the NISA grid. And inside active agricultural fields, we coordinate with our field crew to put them in after they're done with the field prep and before they harvesting. And so we have these different collaborators from USDA mostly. So some folks at Davis are doing orchards. Most of them, many of them are coarser ones where it's only one station per 200 meter grid. But we have several where we have two or more stations in a 200 meter grid. So for example, Oxford, Mississippi, or Columbia, Missouri, University Park is going to have some setups. And the Beltsville is kind of hiding next to Chop Tank. And I've already did some preliminary evaluations for several of these, but it's still in progress. So, and it's not going to be part of this talk. So how our setups look like, it's kind of like on the left-hand side here, with we're measuring hourly so much the data, focusing on 5 centimeters. We have solar panels to help with the power. Actually, we don't have a pheno camera right now, and there's a little air temperature behind it. But other than that, it's a pretty accurate representation of what we have in the field. And so the other slides show the 200 meter by 200 meter grid for NISAR. In some ways, you can have the station set up in there to get the distribution, to characterize some of the inside variability of NISAR data, like within the 200 meter grid. And so here's a link for you can figure out about the overpass data for NISAR mission. They built it out for the whole year, 2026 calendar year. So if you want to do a field measurement, maybe even at your network, so much network sites with some handheld measurements, you can find out what location what tile you're in, and then what date the overpass will be. And unlike some other satellites, it's not really exactly cyclical. I mean, only for your tile, but it's only 2 times every 12 days. But it doesn't mean it's evenly spaced. It could be 2 days in a row, and then you have nothing for the next 22 days or something. So just keep that in mind. It's how it's intended. And so when you're doing field sampling, what we're gonna do is we'll go for these overpass dates. We walk into the field, so some handheld sampling, then cross it and come back out on the other side, just to get some more detailed measurements for the in situ variability, and to figure out how it compares to these three SOMAsh algorithms. And then so we have also vegetation sampling potentially, and soil sampling and things like that. So vegetation sampling is actually important for radar, for modeling. There's something called the water cloud model, where you're trying to take out the vegetation, so you just get the soil signal, then you can get out the soil moisture data from standard equations that are being used. So we want to know things like what vegetative stage is the plant, what's the vegetation content, the water content, how tall they are, things like that. And so this is more detail about our setup, right? Where I mentioned we have 9 stations in there now. It's right here, these two axes. We call it 213 field site. And so 9 stations there, they're working pretty well, except we have some deer messing around with it in the beginning, but it's been letting up. So, and then early July-ish is when the farm crew will let us in there. They'll be done with the field preparation, and we'll deploy it on some of these other grids. Our goal is around 10 grids for validation data. So right now we have 2 in the reference, maybe 10 in addition for the inside corn or soybean during the year. And yeah, so and again, for now, we're waiting for this new data dump. Right now, it's a inconvenient data release only from October through January. The next NISA data release, maybe that's not the beta anymore. It's going to be in July or August, is my understanding. August, okay, August. So it's a little bit of a wait, but in anticipation of that, I've produced like a little tool where we'll just need to put in coordinates of the network. So it'll be a network file, and you just push a button and it'll get all that information, including the RMSE and all of that, just like that. So then that way I can accommodate many different networks, many different temporary networks, so the USCRN or scan, and do some analysis. Also look at the actual rasters to see what was it picking up on, where can it be improved. And down the road, we might make our own SOMASTER product. Here, the slide is just to acknowledge the collaborators that were on the map. There may be some more, but it's just all of those folks we've talked to more frequently than others, and they're closely working with us, getting data at their sites. It's very important for us to have so much setups at different environments, climate regions, soil types, etc., maybe different crops. And always try to have a reference site like we had at Beltsville, because radar data can sometimes be noisy even for the whole tile that's being processed. You want to know what's going on, especially what if you're in a rain, there's some convective system running through, you have rain, it'll change the radar data even at L-band. So you want to be sure to have some reference data where you know there's not going to be a lot of vegetation, or you know exactly what the vegetation is like pasture, let's say, and then you can help make sense what it's seeing at these other stations in the grid. Yeah, that's all I have for here. Thank you.
Do we have questions for Simon?
Yes.
So is NISAR keep all free soil moisture products, or are they after like some powwow, are they gonna narrow that down to one?
That is a $1 million or a multi-million-dollar question.
My guess is all 3 will be available. One of them is from the Indian collaborators, and so they're going to keep their product. And there are 2 other essentially NASA-based products. So my guess is that all 3 will be available. I doubt that there's going to be an official quote-unquote one single NISAR product. That's as I see it.
Although I can, on this point, I can chime in. There's not a single one, but look, so each of these tiles are in HDF5 formatted files, and on HDF5 formatted files, and when you go through data layers, there is one layer where they're just averaging all three together. I mean, whatever that means, but they just take the average. So if you're asking if there's one result for all of them, yes, they do make a single result in the HDF5 file. So you can also just plot that. Actually, that's the one I've been ignoring because I'm looking at each individually. But yes, one could just call up that result and do an evaluation for that. Yes.
Go ahead, Zach.
Quick question, I'm always curious about this, how did you guys choose 200-meter grids?
You know, I can tell you. So it's not really I chose, or this is NASA. Maybe even John knows exactly. But I think this is a holdback from SMAP. They call the Easy Grid, and they want to keep the Easy Grid from like all this SMAP stuff. And so instead of 36 kilometer or 9 kilometer, they're going to 200, and that's a factor of 45. And 200 meter gives you some averaging to get out the speckle noise and all of that. Maybe it also reduces the data still relatively a lot to 10 meters. So it's related to that because the soil measure products, they're actually in a totally different grid than the Easy Grid, like EPSG 6933 or something like that, the global Easy Grid. So you got to take into account that part. But whereas the regular GCOF data is just like UTM zones. And anyway, just saying. So that's how the 200 meter part of it at least kind of came out because they wanted to keep the Easy Grid.
So I'll answer that. Go ahead, ask your question first. I might be able to.
Okay, I just want to make sure I got it right. All this is at 5 centimeters?
Yes.
Okay.
There's some interpretation, there's some argument there, but it's not more than 10 centimeters. I'll tell you that.
Okay.
Yeah. So in the thing, Simon has showed me imagery. I didn't know it was a secret. So
Sounds good. I just didn't get in there.
okay, so there is data, but there's no active ag field data yet.
Right.
But I've seen some very cold field data.
Right. Yeah.
So sorry if I misled. You can have a seat. I'll mention where the NISAR is L-band radar, and the pixel itself is varying depending on where you are in the swath. And nearby it's big, it's high res. Farther away it's bigger. So it's like 5 to 15 meters, maybe 10 meters in dimension. They're not all square. They make them square. And it's an exact repeat cycle. So you're getting the same pixel's going to have the same characteristics every time that ascending or descending happens. And they needed to be on the gridding, and they needed to have enough pixels to overcome signal to noise ratio within that footprint. And there was a debate. They came in and they were more comfortable with a 200 meter to give them enough pixels to get the noise ratio down so that they felt that they could make I think it was a 6% error at 200 meters. There is still potential to do a finer resolution than that. 100 meters is not out of question. You get a little more mixture of the more you increase the noisiness within a pixel when you do that, because you're gonna have some pixels that are very homogeneous, but you're also gonna have a higher ratio of mixed pixel of forest and crop in the same pixel, and you're gonna have less data to work with. So a lot of it was to try and blend a happy medium between what they had in their gridding and what they felt comfortable with on the error side. Also, hey, maybe you get to charge more later for the 100 meter. So it's a planned evolution of your product in some ways. So that's my understanding of where that 200 to 100 discussion went. And I don't think they could go below 100 at all. So
Question online if we want to take that.
sure. We have one more. So
Did he mention the algorithms they use for averaging / filtering out the aggregate noise? I think you're kind of touching a little bit on those.
come on up.
Yeah. So my understanding is it's just the average of the three algorithms. So there's a disaggregation algorithm. There's something called physical model inversion. The third one is called time series ratio. And they're all from different outfits. But I think in the product, they're only taking the straight average between the three to make as one of the data layers.
All right, thank you, Simon.